Hello, everybody. So we start now the second session on argumentation theory. And the next speaker is Professor Anthony Hunter of University College of London. And the title of the talk is Argument Strengths in Probabilistic Argumentation Using Confirmation Theory. Okay, thanks, Tony.
Thank you. Okay, so the motivation for this talk is that in real-world argumentation, it's common for arguments to be considered in terms of their strength. So it's common to hear people say, this is a strong argument, or this is a weak argument. Now, in computational models of argument, we have a lot of work on formalisms for modelling arguments and counter-arguments. But there's a lack of adequate measures of strength of arguments. There's quite a lot of work that touches on the topic, so variants of abstract argumentation, in particular ranking semantics, touch on it by introducing a strength value for each argument, or they actually calculate strength value in terms of attacking or supporting arguments. And there's within structured argumentation, there's also work on measuring the strength of belief in premises or using conditional probabilities of the claim given the premises. And these all give insights into the strength of arguments, but I think there's still much more that we could do in measuring the strength of arguments. So in this paper, I am turning to probabilistic argumentation. So I'm going to introduce a simple defeasible logic, very similar to what's commonly used, and then consider how we can bring in confirmation theory to measure the strength of arguments. So the language is a defeasible logic. So we have literals, implicational formulae. So here we've got some examples of the formulae. So bird implies fly, penguin implies not fly, and so on. And the proof theory is modus ponens and ex falso quodlibet. So the modus ponens is very common for argumentation. And an argument is a minimal consistent set of premises that entails a literal claim. So here, given this knowledge base, we've got these four arguments. So bird and bird implies fly, gives us fly, and so on. So to bring in the probability theory, we're assuming that a model is an assignment of truth or falsity to the literals of the language in a normal way. And then we have a probability distribution over sets of models of the language. So down here, we've got an example of a distribution. So if we've got bird, penguin, and fly, we can represent a model by a binary number. So 1 denotes true. So bird is true, penguin is true, and fly is false. So that's a model, and that has the value 0.01. This model has 0.95, and so on. So this gives us a distribution over these models. And the probability of an argument being acceptable is the probability of the literals being entailed by the premises. So if we look at this first argument here, bird and bird implies fly, then there's just one model that pertains to that, bird and fly being true. So that has 0.95, so the probability that we give of this argument being acceptable is 0.95. So this is very similar to what we see in probabilistic logics. And then we can put arguments and counter-arguments into a graph, following Dung's idea. So here we've got an argument that a bird flies, here we've got an argument the penguin doesn't fly, and so on. So now what I'd like to do is look at how we can introduce strength measures. So I'm going to assume that given an argument and a probability distribution, then we can have a function, S, that takes the probability distribution in the argument and gives an assignment in the interval from -1 to 1. So if the value is greater than 0, then A provides a reason for the claim. If the value is less than or equal to 0, then it doesn't provide a reason for the claim. So as this value rises above 0, so the closer it gets to 1, then A gives an increasingly good reason. It's an
for the claim. So it's a stronger argument. So if it's close to 0, then it's a weak argument. And if it's below 0, then we'd say that it's not even an argument. Now in this paper, I'm going to focus on arguments that involve relationships between observations. So the predicates are going to refer to things like birds, flying things, seeing whether something's green, whether it has feathers, and so on. And I'm going to use this subsidiary function, ev, that takes an argument and gives the set of observations in the support of the argument. So if we've got this argument here, so we've got these premises and this claim, so this is our argument A, then the evidence in A is B and G. So it might be bird and green. So if it's bird and it's green, then it flies. So the evidence is these observations. It's a bird and it's green. So before I give specific measures for measuring strength, what I'd like to do is consider some properties that we might think possibly are useful properties for strength measures. So we could debate whether or not we want these properties, but at least I think they give us a framework for thinking about strength measures. So the first says that if the claim of the argument is the same as the conjunction of the evidence, and there is non-zero belief in the claim, then the strength should be below 1, so it's not maximum. So in other words, if we already believe the claim to some extent, and the evidence is not giving us any more because the claim and the evidence are the same, then we don't want to say that this argument is maximum strength argument. There's some weakness there. The second is just saying that if the evidence of two arguments, A and B, are the same, and the claims of A and B are the same, then the strengths should be the same, which is a very simple and obvious equality axiom. The third says that if we've got non-zero belief, if the strength is greater than 0, then the claim conditioned on the evidence should be greater than 0. So in other words, that the conditional probability of the claim given the evidence should be greater than 0. The fourth one is saying that if the claim given the evidence is equal to the claim, then the strength should be 0. So in fact, the final 4 axioms are all about trying to quantify what 0 strength means. And so here it's just saying that if giving the evidence doesn't change our belief in the claim, then it has 0 strength. The fifth one is saying that the evidence given the claim equals the evidence given not the claim. This also suggests that the strength should be 0. So for obvious reasons, the claim is not giving us any more. The sixth is if the probability distribution is a uniform probability distribution, then the strength should be 0. And then finally, the claim given the evidence equals the claim not given the evidence, then the strength should be 0. So 5 and 7 are similar to each other in terms of how they're looking at strength. So I mentioned that in this paper I'm interested in using confirmation theory to define measures of strength. So confirmation measures were originally developed in the philosophy of science to investigate the development of scientific hypotheses. So the idea is that we've got some confirmation measure that takes some evidence and a hypothesis, and the measure is intended to capture the degree to which the evidence supports the hypothesis. And so there have been numerous proposals for confirmation measures in the philosophy of science. And so I've got some down here that I'll mention in a moment. But interestingly, apart from this work by Nicky Pfeiffer a number of years ago, confirmation measures haven't been used in computational models of argument. So Nicky Pfeiffer's work assumed that arguments were conditional probabilities and didn't consider logical arguments and didn't consider counter-arguments. So he started considering confirmation measures, but I think it's worth returning to looking at them. So here are 3 commonly known confirmation measures. So we're going to assume here for our purposes that evidence is a set of literals and a hypothesis is a literal. So Carnap's measure takes the evidence and the hypothesis, and it's the conditional, so it's the belief in the hypothesis given the evidence minus the belief in the hypothesis. And so the more you already believe the hypothesis, the less valuable this evidence is in suggesting or supporting the hypothesis. Then Christensen proposes this measure, that's the hypothesis given the evidence minus the hypothesis given the negation of the evidence. And then Kemeny gives this measure, which is the evidence given the hypothesis minus the evidence given the negation of the hypothesis, and that's normalized. So you can see there's a relationship between these confirmation measures and the axioms that I was suggesting. So looking at how we can use these in argumentation, it's very direct. So we've got this idea of a strength measure. So we've got the argument and the probability distribution, and we're going to consider three possibilities. So the X is either D, S, or K. So this refers to these three measures that we saw here, D, S, and K. So the strength of an argument is the confirmation measure applied to the evidence in the argument and the claim. So we're using the confirmation measure directly, and so it's the evidence of the argument supporting the claim, which we're treating as the hypothesis. So here's an example. In the paper, I give a number of examples that look at different aspects of how these confirmation measures can be used and how they give insights into the argument. But here we've got this distribution that concerns penguins, birds, and capability of flying in the context of a zoo that's got a lot of birds in it. So there's a large aviary. And I'll just focus on these first two arguments. So the first column gives us the belief in the argument, or the probability of acceptability. So according to this probability distribution, we can see that there's a lot of birds that fly, but there's not many penguins. And the second column gives us the conditional probability, so the probability that a bird flies, or sorry, something flies given that it's a bird. And then the third one is this measure here, the one that's the difference between, or the conditional probability minus the original belief in the claim. And you can see here, this is where we the value becomes much lower. So whereas the conditional probability and the original belief are high, this confirmation measure suggests that in fact this is not such a strong argument. And then the remaining measures for this particular example remain high. And as I say, in the paper, we've got further examples that indicate how these different measures may agree or disagree with each other and give different insights into the strength of the argument. Now, in the remaining, returning to the properties we saw, so these are the 7 properties that I gave before, then we can look at these 3 measures that we saw before, and we can see that most of these properties up here are satisfied by these measures. The 2 exceptions are X1, so this property here, and X4, which are related to some degree, that they're satisfied by the first measure. So this measure that considers the belief in the claim conditioned on the evidence minus the original belief in the claim, that satisfies X1 and X4, but the other 2 measures don't satisfy those measures. So there's still more work to be done, looking at how we can differentiate these measures and find properties that distinguish them. Now, in the remaining few moments, I just want to point out something that I look at in the paper, which is this example, which is quite interesting. So here, this is the kind of example we saw so far, where we've just got one defeasible rule. So bird and bird implies fly gives us fly, and it's easy to see reasonable probability distributions that would make this a strong argument. Now, this second argument is bird, and bird implies has wings, and has wings implies fly. So we've got this intermediate step. And one would expect this would have similar strength to the first argument. Whereas the third argument is bird, and bird implies yellow, and yellow implies fly, gives us this claim fly. Now we've got this intermediate step of the bird being yellow. And this seems somehow irrelevant and somehow weaker than the two arguments. And so I haven't got time to run through this example now, but what I do is look at the sub-arguments. And what we can see is that we can still reasonably have a probability distribution that's very reasonable, that would make the second argument strong, but it's difficult to find a probability distribution that would make the third argument strong. So we need to look at the intermediate arguments. So to conclude, confirmation measures allow us to quantify an aspect of argument strength in defeasible logic arguments that's complementary to what we have so far. They can be used to judge arguments and decide which we can regard as strong arguments. We can use them, for example, if we receive an argument from other agents, we can doubt it or question it or reject it. Or if we're trying to persuade another agent, then we may choose the stronger arguments to present. Thank you. Sorry for running over time.
We have time. Yes, Professor Bracken.
Yes, Tony, I hope you can hear me.
I can hear you.
It's very interesting. My question is, how have you taken
the attack relations between arguments into account?
So I looked at it a little bit
in the paper. Really, the attack arguments you're looking at, because you have a probability distribution over the models. So you get a probability distribution both for the arguments and for the counter arguments. So you can look at the strength of both the arguments and the counter arguments.
I have a question. I raised my hand.
Yes, yes, please, Professor Gabay.
So can I ask now, yeah?
Yes.
My question is about the way the methodological approach of Tony. It seems to me what he's doing can be directly first applied to ordinary non-monotonic reasoning, and then if he wants to put argumentation on top, fine. If you take the ordinary non-monotonic reasoning, you have A non-monotonically gives you B, and then you have A and C, might non-monotonic gives you not B. It comes from observation, then the observation has probability, and then you do this machinery on just non-monotonic logic. And on top, you can do various argumentation, do arguments leading to SPIC plus, so you do arguments. Why just jump straight into argumentation and add all kind of components which muddy the methodological structure of what's going on?
I agree with everything you say, except the muddy bit. I come in at argumentation because I know more about argumentation. So I'm interested in understanding more about arguments. So that's why I started there. I didn't feel it was muddying the water, but I agree with everything else you say. And I think that more needs to be done with the argumentation. And I think just rounding off on what I was trying to say about to Henry, I think more needs to be done understanding counter arguments as well.
Okay, okay, thank you. Muddying, I mean more complex mathematics.
Thank you very much. Oh, one more short question, please. Here.
Real quick. When you attribute values to the strength of an argument, you use negative values as well. Because if I recall, it was between -1 and 1. But then everything below 0 seems to not play any role at all. So I'm wondering if there's a practical reason for that. Because I wonder why not using the range.
I didn't give any examples, actually. That's true, where the strength is below 1. But I think the values below 1 do tell us things about the argument. They tell us negative things about the argument, not to overuse the word negative. I mean, I think they tell us how bad an argument is when it's below 1. So I think it's valuable to have the strength measure below 1.
Okay, thank you. Thank you. So time is over. Thank you very much, Tony. So next talk in this session is by Professor Henry Prague from Utrecht University and Groningen University. And the title is Philosophical Reflections on Argument Strength and Gradual Acceptability.
Thank you. I hope you can all online also see me, even my head. So how do I check? I can change this as well. I'd like to start by thanking the program chairs for being so open-minded to accept my paper, even though it's not at all a typical ECSQARU paper or even a typical AI paper. There's no new formalism, no technical results, just some informal philosophical thoughts about a recent development in the formal study of argumentation, which is the development of gradual notions of argument strength and argument acceptability. And you just saw a very interesting example of that study. Now yesterday, Dung's approach to the theory of abstract argumentation frameworks was mentioned a few times, where you just have a set of arguments, you don't say anything about how they look like, and you just have a binary relations of attack on this set of arguments. You don't tell where it comes from. Bipolar frameworks add to that abstract support relations between arguments, and then essentially the evaluation of arguments is three-valued. They are either skeptically acceptable, so in all extensions of a framework, or credulously acceptable in some but not all extensions, or they are not acceptable, so in no extensions of a framework. People have been dissatisfied with that, and they have said there should be more fine-grained notions of argument strength and acceptability. I think that's a very good idea, but I do think that when developing such notions, some things have to be kept in mind. First of all, I think you have to be explicit about the kind of argument strength you are modeling, because I don't think there's a unique notion of argument strength. And secondly, I think you have to take the nature of arguments and their relations into account. So I don't think purely abstract approaches are the way to go. I first want to say a bit more about this last point. So these are examples of two arguments. It looks formal, but it's just informal notation. So imagine a debate between two politicians. One says we should lower taxes because that increases productivity in society, which is good. And the other politician says we should not lower taxes because that increases inequality in society, which is bad. So some of you will recognize this as instantiations of the argument schemes from good and bad consequences. Now, if you model this in a Dung-style argumentation framework, then one approach, and this is the approach Dung himself took, and also many other people in the early days after his paper, you fully abstract from the structure of these arguments, and you have just two nodes, A and B, with an attack relation between them, because, and why is that? Well, and then you see that in the nodes of the framework, you abstract from a lot of internal structure, because both arguments have two premises and a conclusion. And oh, there's still some animations. I hope you can see them at home. And you now see why they attack each other, because they have contradictory conclusions. So in this idea of what arguments are, they are, well, really what philosophers call arguments, inferential structures with premises and conclusions, and maybe even more complex with intermediate conclusions. However, recently you see another interpretation of the nodes in argumentation frameworks, which interpretation is almost never made explicit by the authors. You have to infer it from their examples. And that is when the nodes in the frameworks correspond to statements that can be true or false. And then you really need bipolar frameworks. You also need support relations between arguments to capture the inferences, the inferential relations. So for instance, one way then to model my example would be you have one argument corresponding to the statement we should lower taxes, and you have another argument corresponding to the premise lower taxes increase productivity, and somehow the goodness is modeled in the support relation between B and A, which now becomes a kind of reason to accept the conclusion. And then the counter-argument is modeled. We have another argument C corresponding to the statement lower taxes increase inequality, and somehow the badness of that is reflected in the attack relation between C and A. So you see what on the previous slide was all inside a single node in the framework is now distributed. The argument is now distributed over the nodes of the framework. And I think it's important to be explicit how you interpret the nodes in the DOOM or the bipolar frameworks, because networks of statements simply obey different theories, different principles than networks of arguments as inferential structures. And I will try to give one or more examples of that difference later on. Oh, that should have been there. And then another recommendation of myself is that I think we should be explicit of the kind of argument strength that is modeled. I mean, philosophers and argumentation theorists have often distinguished three kinds of argument strength, going back to Aristotle: logical, dialectical, and rhetorical strength. So logical strength is the validity of arguments given their form. And I think it's good to distinguish between two kinds of logical strength. Internal strength is where you only look at the argument itself. For instance, saying that a deductive relation between premises and conclusion is stronger than a defeasible relation is an example of internal strength of arguments. What is contextual strength? Then you evaluate the strength of an argument given its relations with other arguments, given the support and or attack relations with other arguments. And that's what we model, for instance, in DOOM frameworks or in bipolar frameworks or in more concrete systems like assumption-based argumentation, aspect plus, and so on. Now, some of you might find this surprising. You might say this is dialectical strength because you look at argument and counter-argument. But this is not really the case, I think, because you only look at the product, the arguments and their logical relations, and you don't look at the dialogical context in which the argumentation takes place. And that is really what dialectical strength looks at. That looks at what is the result of testing an argument through critical discussion. And then, for instance, one principle of dialectical strength could be how challengeable, how vulnerable to attack is your argument in the current context. For instance, decision makers whose decisions are subject to appeal know that it's not good to give a too detailed justification of your claim, because the more details you give, the more reason you give for appeal, for success in appeal. So you have to sparsely justify your decisions. But another aspect could be, a more positive aspect, that if your argument instantiates an argumentation scheme, then the more critical questions of that scheme you have successfully answered, the better your argument is dialectically speaking in the dynamic context. Finally, rhetorical strength, maybe more familiar to you, that is how persuasive the argument is for the audience that has to evaluate the argument. Now, in my paper, I make the claim that it's important, first of all, not to confuse these three kinds of argument strength, but be aware of what are you modeling in your paper, in your approach. And secondly, I don't think it's a good idea to mix them together in a final overall notion of argument strength. I don't think that's a very fruitful idea because, yeah, you need different aspects of strength of an argument in different contexts. Okay, now some informal but hopefully precise examples of where it's important to make explicit what kind of argument strength you are modeling. These are two arguments. At the abstract they would be just A and B, but they have some internal structure. You see argument A infers R from P, and argument B does the same but with an intermediate inference via Q. Now, according to the principle I suggested, you might say that argument A is dialectically stronger, but since it has fewer attacking points, so less challengeable. But if you measure rhetorical strength in terms of the overlap with the background knowledge of the audience, and for instance, the audience accepts that P implies Q and Q imply R, but it doesn't accept that P implies R, then you might say that argument B is rhetorically stronger because it more overlaps with the background knowledge of the audience. With argument B, it understands how to get from P to R. So arguments can at the same time be dialectically stronger but rhetorically weaker, or the other way around. So you have to be explicit about what kind of argument strength you are modeling. Another example where it's important to be aware what kind of argument strength you're modeling. This is, again, to Doom framework, so the arrows are now attack relations. And it has been suggested, for instance, that the more attacks an argument has, the weaker it is. So that means in this example on the right, that argument E is weaker than argument B on the left, because E has two attackers, B has just one, and that in turn makes argument D better than argument A, stronger, because its attacker is weaker. However, suppose this framework came about in an instantiated structured approach to argumentation, maybe assumption-based argumentation, aspect plus, or classical argumentation, and all these systems have classes of arguments that cannot be attacked. And now suppose that argument C is not attackable in the underlying account of argumentation, while arguments F and G are both attackable. Then my intuitions are that from a dialectical point of view, actually D is stronger than A, because B is dialectically much weaker than E, because B can never be made acceptable anymore, because it's attacked by an argument that is acceptable and will remain acceptable because it's not attackable. And that's not the case on the right. Incidentally, this also shows that a purely abstract approach to argument strength has another danger, namely that you may implicitly make assumptions that are not satisfied by all instantiations, such as in this case, that all arguments are attackable. Then an example where it's important to be aware, for instance, whether you are modeling rhetorical strength or not. This is an example where principles have been proposed to the effect that argument A on the left, so again these are Doom frameworks, in all Doom semantics they are both skeptically acceptable. A has no attackers and B is defended against attack. However, I read a very interesting paper by Elise Bonzon and colleagues where they try to model a principle apparently from philosophical studies of rhetoric, prokatalepsis, which says that if you are a speaker, a proponent of an argument, and you anticipate and refute possible counter-arguments before they are raised by the audience or by your opponent in the discussion, that makes your position stronger. So then it could very well be that according to this principle, argument B is actually stronger than argument A, because with argument A the audience might still have counter-arguments in mind, while with argument B at least one of them has been refuted. So then you could say that rhetorically speaking, this principle that has been proposed in the literature does not hold. So it again depends on what kind of argument strength you are modeling. Then some examples. I think one example of why it's important not to ignore the structure of arguments and the nature of their support or attack relations. Here it's support relations, so these are two bipolar argumentation frameworks where the arrows correspond to support. And it has been proposed that the more supporters an argument has, the better, the stronger it is. So that would mean that argument D on the right is better than argument B on the left because it has two supporters and B has only one supporter. Now this may make sense if arguments are interpreted in these frameworks as statements that can be true or false, because then you can say there are two reasons for D and only one for B. But if arguments are inferential structures, then things may be completely different. And so here I give them some structure. Argument B infers R from Q, and argument D infers C from two premises A and B. Now several ways to interpret support have been proposed in the literature in terms of the structure of arguments. Let me just use one for the sake of illustration, where we say that an argument supports another argument if the conclusion of the first is a premise of the second. So you support an argument by providing a further argument for one of its premises. And let us then say that the premise of argument B is provided by a further argument A, and for one of the two premises of argument D, there are two alternative supporters. One based on premise B and one based on premise E. Now the principle that was proposed says that argument D is now better than argument B, but I would say, why is that true? Because all of the premises of argument B on the left have supporters, but only one of the two premises of argument D on the right has supporters. So I think this illustrates that it is also important to take the structure of arguments into account when proposing principles for argument strength. Okay, I think this is it. So to conclude, I think it's very interesting, all this current work on more fine-grained, gradual notions of argument strength and acceptability. I'm now myself working on dialectical argument strength. But I think it's very important to be explicit in your models of what you are modeling, so which kind of argument strength you are trying to model, logical, dialectical, or rhetorical strength, and also how you interpret the nodes in these argumentation graphs that come from argumentation frameworks. Are they really genuine arguments in a philosophical sense that can have a lot of internal structure? Supports are then inside the nodes of the graph, or are they just statements that can be true or false, and then the supports have to be between the nodes in the graph. And finally, I think it's very important to also take the structure of arguments and their relations into account. So I think that purely abstract approaches are very limited in this topic. Okay, thank you very much.
We have time for short questions. Yes. Tony, please. You can hear me?
I don't think
I also, Tony is asking you to start.
Tony, we can't hear you.
Sorry. That was a very nice talk, Henry. I completely agree with everything you say. But I think it's even more complicated because I think the audience needs to be taken into account. So often, I think discussions in our fields suggest that there's some objective view on all of this, and yet different people respond in different ways to arguments, whether it's according to logical, dialectical, or rhetorical criteria. And I think this is also very, very important.
Well, I would say that the audience is very important in rhetorical accounts of argument strength, because that's defined by how persuasive an argument is for an audience. But I think you can study logical and dialectical argument strength abstracting from an audience. For instance, logical argument strength is you just look at the arguments themselves and the information you have about the arguments. And dialectical argument strength looks at, well, the procedural setting. Hey, every dialogical interaction is governed by protocol rules, and then dialectical argument strength is defined in terms of what these protocol rules for argumentation allow you to do. So I think...
Even at the logical level, if you look at a graph and you've got A attacked by B, then you might say, well, look, everybody thinks that B attacks A, and so therefore A is defeated. But it's often quite a subjective matter whether people think that B really does defeat A.
Yeah, but
so do you deal with that at the logical level, or do you deal with it at the rhetorical level? To me, I think the audience comes in at all levels to determine whether or not you've got a valid argument, whether you've got a valid attack, which arguments are acceptable, and so on.
Well, in my approach, that would be part of the input at the logical level. So you might have, as you know, there are extensions of argumentation systems where you can also argue about preferences or attacks, which is Sanjay Modgill's extended argumentation frameworks. I also want to look at that, but I think you can still model different opinions on whether an attack succeeds, whether it's strong enough to attack its target at a logical level, for instance by modeling reasoning about priorities or about whether attacks exist.
Can I now say something, Chairman?
Yes, please. Very short question, Professor
Yeah,
Gaba.
I just want to say that this is a very important lecture because it tells the argumentation community that they have to think more.
Yeah, thank you very much.
No, I haven't finished. One more sentence.
Yes.
The proper presentation of an argumentation network is a graph plus an application area where this graph is to be used, as that includes all this discussion with Tony and so on, plus, and that's important, what algorithm you want to use for whatever considerations you are applying in the application area. So this is a triple. And to understand that, think of logic itself. I have for years been saying that classical logic is not just itself, it's also which proof theory you use for it. Gentzen, Tableau, resolution. Together, they make the system. And here you need this triple at least. Maybe you add audience. But the most important is that some of us, like Henry, are urging you to think.
Thank you very much. Thank you. Again,